What if I told you that everything you've ever known, every person, every planet, every star in the night sky, came from absolutely nothing? Not empty space, not darkness, nothing. No time, no physics, no laws of nature, just void. And then, in a fraction of a second so small we don't even have words for it, everything exploded into existence. This is the story of the most violent, mysterious, and beautiful event in history. The moment that created you, me, and 200 billion trillion stars. Welcome to the birth of reality itself. 13.8 billion years ago, there was no universe, but there was something, a singularity. Picture this. Every galaxy, every atom, every bit of energy that exists today crushed into a point billions of times smaller than the head of a pin. Temperature? Infinite. Density? Infinite. The laws of physics? They didn't exist yet. Even Einstein's equations break down here. We're standing at the edge of what science can explain. Then it happened. Not an explosion in space, because space didn't exist. An explosion of space. The Big Bang wasn't a bomb going off in an empty room. It was the room itself being born. Time started ticking. Space started stretching. And in the first trillionth of a trillionth of a trillionth of a second, the universe inflated from smaller than a subatomic particle to the size of a softball. That's faster than light. Way faster. In fact, nothing in the universe today can move that fast. But this wasn't movement. This was space itself being created, and the rules hadn't been written yet. Now here's where it gets wild. In the first second, just 1 second, the entire universe was 1,000,000,000,000 degrees hot. That's not hot like the sun. That's not hot like anything we can imagine. At this temperature, atoms can't form. Molecules can't exist. There's just pure chaotic energy with particles and antiparticles blinking in and out of existence like cosmic fireworks. Quarks are slamming together. Gluons are holding them in place. Everything is moving at nearly light speed, and it's all happening in a space smaller than our solar system. 1 second. That's all it took to go from infinite temperature to 10 billion degrees, cool enough for the first protons and neutrons to survive. But here's the terrifying part. If the universe had cooled just slightly faster or slightly slower, none of this would have worked. No atoms, no stars, no you. The margin for error was impossibly small, and somehow, against astronomical odds, everything lined up perfectly. 3 minutes in, nuclear fusion kicks off. Protons and neutrons are smashing together, forming the first atomic nuclei: hydrogen, helium, a tiny bit of lithium. These 3 elements, and only these 3, will be the entire periodic table for the next 380,000 years. But the universe has a problem. It's too thick. Light can't travel. Photons are being born and immediately absorbed by a dense fog of electrons and nuclei, bouncing around like balls in a pinball machine. The universe is glowing, but it's blind. No observer could see anything, even if they existed. It's like being trapped inside the brightest fog you can imagine. For 380,000 years, this continues. The universe expands. It cools. It waits. And then the fog clears. The temperature drops to 3,000 degrees. Electrons finally slow down enough to be captured by nuclei, forming the first complete atoms. And in that instant, light breaks free. For the first time in cosmic history, photons can travel across the universe without being absorbed. This light, this ancient flash from the dawn of time, is still traveling through space today. We call it the cosmic microwave background, and it's the oldest thing we can see. When scientists mapped it, they found something incredible. Tiny wrinkles, barely their temperature differences of a few millionths of a degree. These imperfections were the seeds of everything that came next. Welcome to the Dark Ages. Not on Earth, there is no Earth yet. This is the cosmic Dark Ages, and they lasted for hundreds of millions of years. The universe is dark, cold, and filled with invisible hydrogen gas drifting through the void. No stars, no light, just darkness and gravity, slowly, patiently pulling matter together. Those tiny wrinkles from earlier, gravity is amplifying them. Dense regions are getting denser. The gas clouds are collapsing, heating up, getting more and more compressed. Pressure is building. And somewhere, in countless locations across the dark universe, a threshold is about to be crossed. 100 million years after the Big Bang, the first star ignites. And this isn't some ordinary star. The first generation of stars were absolute monsters, hundreds of times more massive than our sun, burning blue-white and furiously hot. They lived fast, died young, and changed everything. Their light ripped through the darkness, tearing electrons off atoms and reionizing the universe. The Dark Ages were over. But here's the thing. These stars were on a suicide mission. They burned so hot and so bright that they consumed their fuel in just a few million years, blink of an eye in cosmic time. And when they died, they didn't fade away quietly. They exploded as supernovae, with more energy than our sun will produce in its entire 10 billion year lifetime. And that's when the magic happened. Inside these dying stars, extreme heat and pressure forged new elements: carbon, oxygen, silicon, iron. All the heavy elements that make up planets and people were created in the final moments of these stellar giants, then blasted across space like cosmic shrapnel. The universe was being seeded with the ingredients for life. Gravity wasn't done. On larger scales, something invisible was at work. Dark matter, mysterious stuff that doesn't emit light, doesn't interact with normal matter, but makes up 85% of all matter in the universe. It was building scaffolding, creating gravitational wells that pulled normal matter together. 500 million years after the Big Bang, the first galaxies assembled. They weren't majestic spirals like the ones we see today. They were small, chaotic, irregular clumps of stars, smashing into each other and merging in violent collisions. Each collision triggered new waves of star formation. The universe was becoming a construction site on the grandest scale imaginable. And at the centers of these young galaxies, something terrifying was forming. Supermassive black holes, millions, sometimes billions of times the mass of the sun, with gravity so intense that nothing, not even light, could escape once it crossed the event horizon. They're still there today, lurking at the heart of nearly every large galaxy, including our own. Fast forward to today. It's been 13.8 billion years since that first moment. The universe now contains 2 trillion galaxies that we can see, and that's just in the observable universe. Beyond that, we don't know. It might be infinite. These galaxies aren't randomly scattered. They form a structure so vast it defies comprehension, the cosmic web. Imagine sheets and filaments of galaxies stretching across hundreds of millions of light years, surrounding enormous voids where almost nothing exists. It looks like neurons in a brain, like the universe is a living thing, thinking thoughts we can't begin to understand. Our Milky Way galaxy formed about 12 billion years ago. 4.5 billion years ago, in one of its outer spiral arms, a cloud of gas and dust collapsed to form our sun. From the leftover material, planets formed, including a small blue world in the habitable zone, where liquid water could exist. But here's what keeps scientists up at night. The universe isn't just expanding, it's accelerating. Something called dark energy, which we don't understand at all, is pushing space apart faster and faster. It makes up 68% of the universe, and we have no idea what it is. So how do we know any of this actually happened? The evidence is everywhere. The cosmic microwave background shows us the exact pattern of temperature variations from when the universe was just 380,000 years old. We can measure the ratio of hydrogen to helium in the universe, and it matches Big Bang predictions to ridiculous precision. We can see galaxies moving away from us in every direction. The farther away, the faster they're moving. We can literally look back in time by viewing distant galaxies, watching the universe as it was billions of years ago. Every piece of evidence points to the same conclusion. This all really happened. Think about this. The atoms in your body right now, the carbon in your DNA, the calcium in your bones, the iron in your blood, were forged inside a star that died billions of years ago. That star exploded, scattering its atoms across space. Those atoms drifted through darkness for millions of years until they found their way into a cloud of gas that collapsed to form our solar system. They became part of Earth, and eventually, impossibly, they became you. You are not just in the universe, you are the universe, conscious, aware, asking questions about your own origin. Against impossible odds in an infinite cosmos, matter organized itself into structures complex enough to look back across billions of years and figure out where it came from. Stars had to form, explode, and die. Galaxies had to collide. Planets had to congeal. Life had to emerge. Evolution had to run its course, all leading to this moment right now, where you're hearing this story. We are the universe waking up. We are the cosmos contemplating itself. We are stardust that learned to think. And the story isn't over. The universe is still creating, still evolving, still expanding into an unknown future. We're living in the middle of the greatest story ever told. A story that started with nothing, created everything, and somehow, incredibly, gave birth to beings who could understand what happened. From an infinitesimal point of infinite density to 2 trillion galaxies and counting, from the Big Bang to this moment, from nothing to everything. That's not just science, that's magic. And it's all true.